All right, welcome back. We are into week 7 now, and this lesson we're going to be talking about moving from a data model to a relational database design. All right, so keeping in mind that your data model was in the abstract world. It lived up here. And that's your data model comes out looking, let's go up here, kind of like your UML. So you've got your classes, your relationships, your attributes, that kind of stuff. That's all on paper. This is not what goes in the database. This is a design factor, and that's where we live in with the abstract. And it gets very higher up into computer science you get into it, people get more and more in this whole separation of this. So just try to keep in mind that while you're still building a UML, while you're building an ERD, if you want to call it like, entity relationship diagram, when you're diagramming stuff out, diagramming use cases, you're still existing in the abstract world. This isn't something concrete you're going to put into a database management system. So let's go ahead. What happens if we look down here? So, what's the difference? Once we start moving, you see we're moving down here into the bottom right quadrant, which is table design in the design side here. So what we're going to do here is we're going to have, where we looked at, we had classes before. And again, the classes for reference are, this is a class, this is a class, this is a class. And the classes will have a name for the class, and they'll have attributes, and they will likely show their relationship. In the technique in the relational database, you're going to create a table and with a primary key. Now, I would say most of the time. You can have tables without primary keys. They're not required all the time. Okay. We'll take the attributes from your UML, your class, and we're going to create fields or columns with an appropriate data type in the table. Objects, we're going to add a row of data to the table. Again, this object thing. Let's just, we'll call this importing data, import or create data. The one-to-many relationships, we'll use a foreign key in the table on one end of the relationship, and we'll add that to the table. So that'll point to the primary key of another table, whatever you're relating to. With your many relationships, when you implement that, you're going to do that as it's an intermediate table with two foreign keys. I call it a lookup table. You can call whatever you want, intermediate, lookup, but that's the idea when you have multiple many-to-many relationships. And parent-child classes, build, as you're looking at your parent-child, like your subclasses here, like your book, we have ordinary reference book. Think about, you want to build this table first. This table's built, and then you'll create these two tables with a database. That way they can inherit any functions you have going on there, okay? It's kind of weird writing this down. It's something more usable once you're actually in there working on it and doing it. All right. So again, keep in mind, classes become tables, attributes become fields, columns. I know it's fields in the books and fields in the test, but out in the real world, everybody calls them columns for the most part. Your data types be specific to the data stored in the field. And you want to provide the features, constraints. You only enter numbers instead of letters. Or if you have an email, you'd want to set it up so it has to have that @ sign. And let's say you have a constraint with just the standard US zip codes, which are 5 digits. You could set the thing to only have 5 digits in there. You could set up calculations, ordering, all kinds of stuff like that within the data type. But you just want to make sure you pick the correct data type for what you're doing. Primary field is a field or combinations of fields that's guaranteed to have a unique value for every record in the table. Again, like I say, especially if you're in my class, think of your G number as a great version of a primary key because it's a unique number to you. Another thing you could think of is social security number. You could think of, when you're a customer, you would have a customer ID, that kind of thing, because if your name's Bob Smith, there's probably more than one Bob Smith in that, that's a customer of that company. So they use an ID. You can use multiple fields as a primary key, in cases like that. Some situations I think of, you could have a field, a series of transactions, whatever it is, and you don't have a transaction ID, but you could take the customer ID and the date stamp of the transaction, because assumingly, especially if you're date stamping down to the second, there should only be one transaction per second for any given customer. So those two combined would make a primary key because they would guarantee that that's a unique row. Okay. Uh, a lot of times you can use auto incrementing number as a primary key. I believe that was called in Access, it was called auto number is the, and in SQL Server, we call that, called an identity. And it's one of those things, and if you go into, I'm not sure Oracle or Teradata what they call it off the top of my head, but you can go to something like Stack Overflow, and they'll tell you what to call it. A concatenated key is, again, when we were talking earlier, I talked about the primary key that was a combination. And here they've got down here a combination of a primary key where they've got the student, the course, and the year with a grade. And I don't like this one at all, because you could, let's say you bombed the class, you took it in the spring semester, didn't do well, so you went to take it again in the fall. So it'd be the same year, just, you have 2 grades there. So, but that's still the idea that technically, if you only could take one class, you could not take this class more than once in a year, then yes, this would work, because every row would be unique of the 3 combined, things here. Concatenated primary keys are sometimes more trouble than they're worth. We use them in the real world, but like for your project, I would stick to an auto number. Just make life easy. Either an auto number or create like a unique identifier, kind of like your G number for class. All right. From data model to relational database, okay, say relationships. So the foreign key refers back to the primary key. And again, we look here and all right. So you might have, to get an idea, you'd have a primary key in here you might have is like, if we went up there to play around, you could have an ID number for this person. And then for the loan, you could have an ID number in here that referenced back. And that would be your foreign key, because it's from this table referencing another. I know we've gone over this a few times, but but that's the primary key. That's how it works. The foreign key is related to the primary key and goes back to it. And that's where you can see this can be a real pain in the butt imagine trying to make a foreign key to match this primary key. It's additional headaches that you probably don't want to deal with. And that is how we establish relationships between objects in different classes. This is important to remember, because the second part of the class today, we're going to be going over joins in SQL. And this is the whole idea behind how joins work. Referential integrity. This is a constraint you put on that says the value in the foreign field must exist as values in the primary field. And I know we've gone over this a bunch of times. We go over it a bunch of times, so this kind of sticks in. Prevents you from adding non-existent values and prevents you from removing utilized values. So I know an example I use all the time. Let's just say I had a database that stored Major League Baseball teams. So using referential integrity, I would have a table with team names on it, and I'd have another table where I'm maybe setting up games. I can't pick a team that's not in that table. So I can pick the New York Yankees. I can pick the San Diego Padres. I cannot pick the Sheboygan A's because they don't exist in that table. This is just not something you do. So that's what referential integrity does. It ensures that what you're referencing exists and you're not putting in false and bad information. It's a way of data integrity. It's checking that issue for you, which is an important thing when you're putting together databases. All right, let's go ahead. And so we talked about the one-to-many relationships here. So a one-to-many, you've got a course and you've got a lecturer. You have a lecturer ID. So one to many, course table, the lecture table. as each course has only one lecturer, so the foreign key would be in the course would be lecture ID. So this would be your foreign key. Okay. And that's your one-to-many. We've done that. This one that's like I say that this is the one you deal with the most. It's probably the most common relation. The many-to-many becomes a situation of here where I've got cocktails, I got ingredients, and you can use more than, for those of you who don't drink, margaritas use tequila, rum uses daiquiri, but you could have another drink like a tequila sunrise that would use tequila. You could have, I'm not sure what a cable car even has in it. Here, I'll change this to, what, just call this a rum and coke. That's simple enough to know what's in that. So you could see where rum would pop up more than once. You'd have a many-to-many relationship here. And that's what we created, was this reference table. And it got cocktail ID, ingredient ID, and how much to put in. So this is 1.5 ounces of tequila, half an ounce of triple sec. You put your lime juice in there, wherever else you want to do it. So for this rum and coke, we would actually have to have another ingredient here, coke. And we'd have rum, it'd be 3, be rum and coke. All right. So this is how you have to do it. You need 2 foreign keys making up the reference table. Now you really want to sit there and think about it. This is a case where you could put an ID number here. And I advise for your project for this reference table just to put an ID, so we always have unique rows there, make that your primary. Although if you want to do something like this would be a situation where making these 3 your primary key would kind of make sense because they're both just foreign keying off 2 other tables. So I would just say that, keep it simple. Think of the simplest solution you can when it comes time. And sometimes just making the simplest solution is just putting in an auto number ID column. Okay. Now, when we've got inheritances, we got to make sure that, inheritance is not built into the databases. We kind of infer it through this method. It's not like when you're dealing with object-oriented program where you can inherit from different, you can inherit a method from a different class, that kind of stuff. It's just more of an inheritance in the structure than it is in actual integrity. So you want to make sure that you build the superclass first. So when you're building out your database, you build out the superclass first. Then when you create your subclasses, you're going to create subclasses that will foreign key reference your main table. So definitely has the foreign key in there referencing the main table. All right. So that is the biggest thing to think about is, again, we don't have any way of like enforcing some type of inheritance like you would in object-oriented programming. It's more of a structural inheritance at this point. And to keep in mind when you self field. So you can see here, you have members and you need a sponsor. So apparently Bob Jones likes to sponsor people because both Linda Green and Jim Smith are both sponsored by Bob Jones. But Bob Jones was sponsored by somebody else, 216, who is somewhere else in the database. We just can't find him, right? They just didn't give us enough data here to look at it. But that's the idea when we're starting to take these concepts and we're going to put them into actually building out our database, okay? And like I say, for the next lesson, we're going to be going to look at some joins in SQL, and that will kind of help infer some of this information we've been going over. And after that, then we'll start to get into actually building out a database within SQL Server. You've already built one, played around a little bit with an Access, but now we're going to do it in SQL Server. All right. Well, thank you for watching this, and I hope to see you in class again soon. Thank you very much.